Okay, let's see what is binary search. The idea is search for a key element in an ordered list. Okay, for example, in this list of items, okay, it can be implemented as an array, which is the most direct consideration, and also it can be implemented as linked list. So you're looking for, okay, an item just like 22 in this case. So you can just recall the game, okay, in Chinese 超級無敵開口中, okay, is actually try to identify a number from the range, from the widest one, okay, and then nail down the number up to a point that, okay, the upper limit and the lower limit is nailed down so that it converts to one single number, right? So to visualize the case, okay, let's see. The idea is just like this. Okay, if the target is greater than the middle one, okay, just like this one, so then we recur on the second half of the sequence, that is this part. Okay, imagine that we are looking for 22. So the first sequence can be ignored because it has to be found in the second half of the sequence. And then if the target is less than the middle one, then it has to be in the first half of the sequence, not the later part, right? Okay, the logic follows. And eventually, if the targets equal to the data mean, okay, so we know that the data is fine. But I would like to state another case is that if we find that the number is not fine, it is not an error. It just finds that the target item is not in the list. So you can see that the operation has the pointer, okay, the low, high, mid. It will change according to the sequence when we concentrate on a half of the list, just like, okay, in the first case, when we know that the sequence is found in the second half, then the low is actually moved to the one of mean, and the mean will go to the middle of low and high, and so on and so forth, so that the range of the sequence being looked at will be narrowed down.